We looked at this example in the first part where we got the acceleration as 2 meters per second squared. Now let me ask you a question. Can the acceleration be negative? To know the answer, let's continue with this example. From point B, the object moves towards point C and the velocity at point C is 4 meters per second. From point B, the object took 2 seconds to reach point C. What will be the acceleration in the second case? It's easy. The acceleration formula remains the same. Final velocity v minus the initial velocity u over the time taken. In this case, the final velocity is 4 meters per second, the initial velocity is 10 meters per second, and the time taken to reach C from B is 2 seconds. So the acceleration here will be 4 meters per second minus 10 meters per second over 2 seconds. -6 over 2 will give us -3 meters per second squared as the acceleration. There you go. Negative acceleration is possible. What is happening in the second case? The object slowed down. Now I am going to ask you a very important question. Are you ready? Okay, here it goes. Does negative acceleration always imply that the body is slowing down? For instance, in the second case, the acceleration was negative and the body slowed down. Can the body pick up speed when the acceleration is negative? Let's move to a new page to understand this. The first thing we should be familiar with is the sign convention we use. Like our coordinate system, right is positive and left is negative. Similarly, moving up is positive and moving down is negative. But normally when we look at motion, we will be using the horizontal axis. So we should know that right is positive and left is negative. Now let's divide the whiteboard into 4 parts to understand something interesting. Look at the 4 different cases given. In each case, the body is moving either from point P to Q or from point Q to P. When the body is moving from point P to Q, we see the velocity is positive because it's moving towards the right or towards the east. But when the body is moving from point Q to P, the velocity is negative. U is the initial velocity, V is the final velocity, and T is the time taken. Now I want you to try finding the acceleration in each of the 4 cases. Don't forget the sign. The calculations were simple, but in which cases do you think the body is speeding up and in which cases is it slowing down? In these 2 cases, the body is speeding up. In both cases, the speed increased from 10 to 20 meters per second. And the other 2 cases, the body is slowing down. The speed decreases from 10 to 5 meters per second. When the body is speeding up, is the acceleration always positive? Not really. We also see a case when the acceleration is negative. And when the body is slowing down, we can also see a case when the acceleration is positive. So remember this. Positive acceleration does not necessarily mean the body is speeding up. And negative acceleration does not necessarily mean the body is slowing down. So when can we say that the body is speeding up or slowing down? Look at the first column. When the body is speeding up, the signs of the velocity and the acceleration are the same. And when the body is slowing down, the signs of the velocity and acceleration are different. Yes, that's what we can conclude. When the acceleration has the same sign as the velocity or the same direction as the velocity, then the body is speeding up. And if the acceleration has the opposite sign of the velocity or in the opposite direction of the velocity, then the body is slowing down. Now let's go back to the very first example we saw. The object moves rightwards from A to B to C. The first case is A to B and the second one is B to C. Can you tell me in which case is the body speeding up and in which one is it slowing down? And why? Clearly, in the first case, the body is speeding up as the acceleration and the velocity have the same sign. And in the second one, the body is slowing down as the acceleration and the velocity have different signs. Surely, you know the concept of speeding up and slowing down by now. In the next video, we will look at the concept of uniform and non-uniform acceleration.